Hi, Nima. How's it going today?
Doing good.
Excellent. IGDA, the global organization, works to present, to try to keep the cutting edge in gaming in going. And usually what that means, if I can gather my words, is sometimes we have technology presentations like we do tonight. Sometimes we have presentations about diversity in your audiences, diversity on your teams. Sometimes we have presentations about workers' rights in the gaming industry. The global organization keeps track of all of our mental health, all of our social health, all of our professional health as individual game developers. So that includes not only indies, but people who work for studios. So we represent y'all, right? And in contrast, the ESA represents the publishers, right? So if you think about it in those terms, we're not a labor union. Anyway, a couple of things we want to cover. If you're an IGDA member, right now you get, and I know I'm speaking to some Unity folks right now, I want to make sure that I get the terms right here, but until Saturday, July 1st, that's this Saturday, if you're an IGDA member, you get 25% off the current purchase price of a 1-year Unity Plus subscription, or 10% off a 1-year Unity Pro subscription. So if you're thinking about making a game, you're thinking about making it with one of the most accessible platforms there is, there's a limited time to get a great discount on it. Additionally, if you're not an IGDA member, dues are only $50 a year. If you're used to the video game industry, you're used to fluid employment, right? So the IGDA actually offers a health insurance policy for its members, through its paid dues members. And if you're currently unemployed, IGDA also offers an unemployed rate, right, which is 25. You know what? I said 50 and 25 without not actually knowing what the dues are. Is it still 50 and 25?
Yeah, so we might be increasing rates, so subscribe now.
Excellent. So we can pay you more.
To put more money back into programs like this.
Oh, it's not a paid position. Okay. Let's see. I'm giving Renee crap because she's actually on the global board. Without much further ado, tonight is Unity Microtalks. We're going to have really quick talks about a lot of different topics in the Unity development engine. And first up will be our proud hosts and sponsors, Unity.
Mike's
Mike,
go ahead. Sean.
Yep, thank you.
Just look at my computer to wake it up. Oh, look at that. All right, so hi. Thanks to everyone for coming out tonight. My name is Mike Durand. I'm an engineer on the XR team at Unity. XR for us is the combination of AR and VR because we've integrated a lot of VR platforms and are integrating more and more AR platforms, and we sort of see the commonalities of all of them, and are pushing this terminology so that we can give people the feeling that they're not all that different, or rather the abstractions that Unity provides helps make them not so different. So just kind of to my first slide, I'm sort of trying to proxy the audience with the questions at the top of these slides, but the VR and AR landscape is a bit of a fragmented one right now, just as mobile was for a long time. Actually, before I kind of go into the motivation for XR and what it means to Unity, is anyone here working on even experimentally like a VR or AR game? Oh wow! Okay, great. Well. The design of this talk, I'm going to give the bulk of it. Matt Dalby is another member of our team, as are Joe and Carrie. They're all on the XR team. And so we're going to try to go through this and then open it up for questions just so that you can kind of understand the work that we've already done, for those of you who aren't familiar, as well as a bit of the work that and useful abstractions that we see ahead of us. So, as I was saying before, VR is, a bit fragmented, as is AR. We have mobile VR, which right now offers 3 degrees of freedom, not like an outside-in tracked environment. So, but then on the other hand, we have devices that are tethered and higher performing therefore with better tracking, such as the Rift and the Vive. And then on the AR side, we have wearables, primarily the HoloLens at this point, which we've integrated for several major releases of Unity now. And then, kind of coming into the scene a bit more, especially with Apple's announcement, is the notion of handheld AR. Everyone remembers a year ago Pokemon Go, which was cross-platform itself using an API called Euphoria, which we have also integrated. So anyway, the point with all of that is to show that, hey, there's fragmentation here. There's different models for spatial tracking. There's certainly across mobile and tethered VR. There's certainly a variance in graphics capabilities. And our goal in the XR team is to provide abstractions across vendors, form factors, and types of experience, including VR and AR. So we want to enable developers to obviously solve all of these problems as similarly as possible for a couple of reasons. First of all, there could be experiences that have, have meaning both in AR as well as VR. And secondly, if someone has built up a sense of how Unity works well for VR and they want to go into AR, well, they're going to have a better idea of how to succeed in writing AR if the APIs and abstractions are similar. So, all of this with the goal of, making it easier for developers. And when we make it easier for developers to target all of these fragmented platforms, we make launching VR and AR titles more viable because you have a better chance of making money at shipping them. So that sounded like a bunch of marketing nonsense. And I can call BS on myself, so it did. But let me talk a little bit, since we're a technical audience here, about some of the things that we've actually done. So in the VR realm, we have the notion of a full-fledged VR device abstraction, which works really well and allows someone to, go into the Unity builds menu, decide, I would like to support both the Rift and the Vive and or Oculus and OpenVR as it actually goes inside of the UI, and write an experience or design an experience in a completely cross-platform way that can run on both. And there's examples out there of games that have shipped that are doing that, and that's our goal ultimately. From the graphics standpoint, like from the first set of bullets, and just from people's intuition, graphics capabilities and chipsets and driver capabilities on mobile devices are a dizzying array of unrelated things. And what we try to do, just like we do on any platform, honestly, in Unity, is we try to make sure that that's a problem you don't have to worry about. If you've configured, for example, double wide rendering as an optimization as opposed to double pass rendering, we can make the decision based on the chipset and your target platform whether there's good enough support for one optimization to work over the other. VR audio is also an underrated but interesting field. We have on our XR team a fellow named Mike Berg, who's a talented sound engineer, and he is integrating some interesting technology from Google, Microsoft, Oculus regarding, HRTF, which, it's got a fancy name, but basically it's the idea that in a VR environment, if we're having a virtual chat session, if we're in a virtual meeting right now, and this person is speaking, if my ear is facing him, I will get more sound in my ear. So it's basically the head-related transfer function is basically that notion. So if Arissa is whispering to me, I have a chance of hearing her if I'm oriented like this. If I'm over here, I probably can't. So it adds a little bit of realism, and as well as in the ambisonics, which is a pretty map-heavy and interesting idea, there's some real perf gains as well. So another really important part of the abstractions that we're providing is spatial tracking. So, and that involves both tracking not only the HMD, but individual eyes, as well as the array of controllers that are available. And Matt's done a lot of the work to solve the problem of normalizing all of this new hardware that's, coming out and yet to come out. So, Matt, if you want to talk a little bit.
So what we're doing on the input or interaction side is that we have this slew of different devices with different capabilities, and we're trying to make it as easy as possible for people to be able to develop and target as many of these things as possible. We're bringing out a lot of new interesting tech in .2, which launches later this year. One of those things is what we're calling the tracked pose driver. It's a terrible name, I'm sorry. And what that thing does is allow you to attach a component to a game object and say, I want this game object to follow the position of the right controller, or the left controller, or the HMD. So you can now do really simple VR experiences with no code. So you can drop in a camera, 2 cubes, hook it up, no code, just some components, done. And then that's our first step. First step of many that we want to do. So for example, there is a labs team in San Francisco who've been working on the VR toolkit. The VR toolkit is including things like locomotion, how to pick up, interaction handling, picking up things, throwing things, all those sort of things that sit on top of this kind of system. So the approach that we're trying to do is make it as easy as possible to target as many different devices and as many different input systems as possible, so that we can let you guys build interesting things without having to worry about supporting different platforms. So part of that as well is we also have the challenge of supporting things like 6 DOF controllers, 3 DOF controllers, and almost 0 DOF controllers, which is buttons. And then also with headsets, so everything kind of needs to work together. And so I think that pretty much is what I was going to say.
Okay.
But it's an interesting thing that we're trying to bring together. The idea that we have is trying to make it as easy as possible to work on multiple devices, and not just the PC-based headsets. Not we want to support mobile, Gear VR controllers, Daydream controllers. Everything is running on top of this system, and we're actually sat on top of the new of the system that's coming from Unity shortly. So this is kind of a bit different. It works on a very event-based sort of mechanism, and this is allowing us to do a lot more sort of configuration. So we have an idea of, we have this idea of action maps. I don't know if you've used action maps in other game engines, but the idea being that you set up an action. So you might find a fire command or a jump command, and then behind that you can then say the A button on my controller is fire, or the A button on my Oculus Touch controller is fire, or the trigger on my Vive controller is fire. And it doesn't matter what devices you have, it just works. And that's what we're trying to get to with future versions of Unity.
Thanks, Matt. So just quickly talk about our supported VR platforms. And kind of just to connect a dot that many of you probably figured out, like when Matt's talking about abstractions like, I want to move this game object with my left hand or my right hand, or I want it to track my head. That's in addition to making it convenient to develop for today's platforms, it also makes it possible to develop for future platforms that aren't even out yet. With, say you release a VR game right now, and in 3 years, some company that out of nowhere comes out with a new entire VR system with its own take on what a left and right controller are. Well, the value there is that you'll be able to leverage that new one if we do our abstractions correctly. And I think so far we're on the right path. So I'll wrap up the pre-questions part by saying, okay, well, sure, what about AR? We've been talking a lot about VR. So AR is not as mature as VR at this point, but it does have similar problems that can be solved in similar ways. Namely, the facilities of abstracting, the graphic systems from developers directly, which is just sort of, par for the course with any platform on Unity. And then also the spatial tracking type work that Matt was talking about. For instance, a couple guys on my team have just integrated Google Tango technology, which is a handheld AR experience. And we leverage the tracked pose driver component that Matt was talking about. We attach it to the Unity camera, configure it to say, hey, follow Tango, and then all of a sudden without writing any code, we already have the camera tracking properly, and with another platform agnostic component, we can pass through images from the camera, so you have, everyone's played Pokemon, so the sorts of experiences that can be enabled with that. So in addition, some other use cases in AR that we are right now have not had the opportunity to solve in a platform agnostic way is 3D reconstruction. So people that have worn a HoloLens understand that, or have played around with the Tango device understand that there's a depth camera that's getting point information, and then we feed that into Unity's physics systems and mesh building system, and okay, now we can represent that wall as a solid object and throw a virtual ball off of it, that sort of thing. Also plane finding and edge detection, which are pretty self-explanatory. That's how you place the Pokemon, right? So then, as we had said before, we did just add native support for Tango and also Vuforia as well in 2017.2, which is going to release later this year in the fall. We also announced at Worldwide Developer Conference that our emerging tech team created a plugin that enables pretty seamless integration with Unity for Apple's AR kit, and there's lots of fun experiences on YouTube right now around that. So so kind of the summary is we're working hard to make VR and AR more viable, finding abstractions that'll help you guys target as many customers as you can, as many platforms as you can now and into the future. And don't know how we did on time, but are there any questions?
Probably have a minute for questions.
Okay.
If we want to include all the Unity people in tonight's talks.
Yeah, sorry.
With the audio that's included for VR currently, do you have just the difference of sound, or do you also have the sound delay between ears as well?
Yeah, that's included. So it at this point it varies from vendor to vendor. So I'm pretty sure that propagation through the skull is included, I think, in Oculus, but maybe not in the Google one. So there's still some evening out, some disparity to figure out. But it's interesting how much work, how much investment these companies are making in sound. So yeah, good question. Yes.
I can't remember which one of you mentioned eye tracking. Who's got an eye tracking platform?
So eye tracking in terms of what we were talking about is if you go into our API, you can query for different, I guess, anatomical components. So that includes left hand, right hand, if they're controllers. Also left eye and right eye, but it's not pupil tracking.
Okay.
So then the left eye and right eye, we also expose the notion of the center eye, which people generally find more useful than left eye and right eye, but people that want to do interesting graphics effects do care about the specific eye locations. Because, oh yeah, hey, how's it going, stranger?
Going well. Good to see you all again. Did you say the new input system was coming in at .2 or
Bits and pieces.
Bits and pieces,
We
okay.
have VR support in .2. The full support for all the platforms for the main. We have a different, what I'm calling backplane. So we have a different event generation for VR.
okay?
Because we have the VR device and VR input abstraction, so we sit on top of that. But actually, all the other devices, that's a separate thing that's happening on a separate platform. So we're actually going to be the first cab off the rank, effectively, with the system. And we'll be supporting it on more platforms, and the actual input system will be supporting it.
Okay. Will VR all be in its own namespace for a while then?
Yes.
Okay.
And at the moment, it's in an experimental namespace, which isn't great, but
Yeah. Okay.
Well, that looks like it. Thank you very much.
I think I'm up next, so you're gonna have to bear with me for a moment while I get my laptop set up, because we're gonna go through the whole switch back and forth and my myriad of liquids as well.
So, what are you going to talk about?
I'm going to talk about the most exciting thing in the world when it comes to Unity, garbage collection. Which, for those of you who've done a lot of Unity programming in a large application, you've probably been bitten by it. If you've worked in small applications, maybe you haven't noticed before, and that's okay. Let's get this guy going. Very exciting. Let me pour my water really quickly. Hi, my name is Sela. I'm a software engineer over at VReal. I used to do a lot of server work, and that's what a lot of people know me from, but now I'm doing a lot of performance work, and I'll look at you guys all now, too. VR streaming is the sort of stuff that we do. So kind of going down to the low level, I do networking, and I do handling garbage collection, handling performance things, optimizations, et cetera, et cetera. So that's kind of been the space I've been living in recently. I also do a lot of work with the IGDA. I'm sitting on the board of IGDA Seattle. I work with the IGDA Foundation at GDC. We put on a scholarship for women who are university students, which is very exciting, and I'm here today. So I'm pretty pleased to do this. So what's garbage collection? How many of you are programmers, first off? Almost everybody, yes, very exciting. Okay, how many of you aren't formal programmers but have done just a little bit of programming or have a little bit of knowledge in that space? Cool, so just about everybody else. So that's really exciting to hear. So if you've worked in something like C++, which given the number of programmers I assume some of you have, you're dealing with memory, and you're dealing with managing it yourself. Memory, for those who aren't familiar, is basically the space inside your application when you are creating new objects. So you want to make a game object in Unity, there's a little place in memory that it's being used. You want to make an integer, there's a different place in memory. Now, it's in the same place, we'll get to that in a little bit, but most of these things end up on what is called the heap. This is our representation of the heap. Very exciting. This is all of the garbage that has been prepared. When you are using a managed language like C#, and which is what Unity uses, and you're working inside this space, instead of manually creating your memory and then deleting it yourself, which many programmers are used to, instead it's going to just happen magically for you. That's what the garbage collector does. When something is no longer being referenced by your application, it's considered garbage and it will get collected. It ends up in this nice little pile and disappears. It sounds really great, right? It's really exciting. You don't have to worry about this, and now your iteration time is faster. Now you don't have to worry about any of these problems. The downside is now there's a lot more challenges. You end up with things like, hey, dropped frames, because every once in a while, all this stuff's got to go away. Yes. So instead of doing it yourself whenever you want, it happens at a time that you have no control over. This can be problematic, especially when you're working in something like VR, where you need to hit 90 frames a second regularly, or else you get sick. So you can't really have these big spikes outside of your control. So you need to learn how to manage your own garbage collector. Unity's GC is the BOEM garbage collector. If anyone's done any formal work in various different languages, you may have seen BOEM. It's 20-something, almost 30 years old now. It's an old research project, and it is old, well-tested, and is used all over the place and everything. But it's also slow conservative, which means that it doesn't run as fast as it can, and instead it kind of stays a little bit safe. It also runs on just about everything in the world, which is really great, and I assume that's one of the reasons Unity uses it. Maybe someone here can correct me. It'll run on pretty much anything you can imagine in any language. So if you're doing anything in IL to CPP, everything is great. You don't need to write a special garbage collector for your new platform. Mono has a new garbage collector, which is really great, except we don't get to use it. So we're still using the old BOEM system. And I'll explain in a little bit why this is a little bit of a challenge for Unity developers. What does this actually do? Well, it's a mark and sweep collector. A mark and sweep collector runs through two different phases when it's processing, whenever you allocate anything. You're going to go through, if you need to create, sorry, let me rewind a moment. The way a mark and sweep collector is going to work is when you go to allocate memory, it's going to go to the heap and see if there's space. If there's space, great. Here you go, here's your memory. Now you've got an object. It'll get referenced. When you lose your reference, it'll get collected eventually and put on the garbage. What's going to happen if you don't have any space left to allocate? Well, now we've got to go through the collection process. So mark and sweep stops the world and goes through two phases. Step one, it needs to look at every single object that it has. It needs to go and see if anybody's still referencing it, and then it needs to go and clear everything out in a second phase if nobody is referencing it. Why do I mention stop the world effect? Well, that can run for a long time. I've seen garbage collections in .NET, in my history, take up to 30 minutes, but that's a whole different story that Unity applications will never get into. That was on a server with 128 gigabytes of memory, and was a very specialized case. About the longest I've seen in Unity has probably been a second, or something like that. But that's 60 to 90 dropped frames, depending on the frame rate you're hitting, and is a big pause that's noticeable to your users in your application. In fact, a couple frames is probably noticeable to your users. It's not generational, which doesn't necessarily mean anything to most people, but a generational garbage collector is kind of a more modern way of going about it. It's going to do track lifetime and basically have a couple of different buckets to put things into. Java uses a generational garbage collector, modern Mono uses a generational collector, and regular .NET also uses a generational collector. So we're kind of in the Stone Age when it comes to GC in Unity land right now. It also has special handling for large objects, but that's not super relevant to what I'm going to get into today. Boxing is one other thing you need to know about memory before we go on to the second phase, which is kind of how do we handle some of these garbage collection issues. Boxing is when you take an object, or when you take a value type, and you want to turn it into an object, which puts it on the heap. Basically, you take the cat, and you put it inside a box. Very exciting. That phase causes an allocation, what I call a secret allocation, to happen because it doesn't show up in a lot of profilers, and you don't realize that you're triggering garbage collection potentially, getting more memory. And it's also an expensive process computationally. So if you're going back and forth between, say, int and object, between various different methods, you might want to reconsider doing that because you're going to end up allocating a lot of memory, causing a lot of garbage collection, and you're also going to spend extra time that you don't need. So instead of doing something like that, you can use generics, which came in .NET 2, I believe, many moons ago, and solved many of these problems. So recently I had a system that I was working in where we needed to treat a lot of different things the same way. So great, because we do streaming, I need to get bits from here, put them over here, great. So we take an int, we take a float, we take vector3, we take anything we want, we would turn it into an object and process whatever we needed to do. Turns out that causes a lot of allocations, it thrashed our heap, and it caused us many, many problems in terms of performance and in terms of drop frames. So instead, I put in a big generic system so that everything is strongly typed, skipping some of those problems. Common garbage collection issues is kind of the second phase of what I'm doing here. We talked about Mark. This is our sweep now. We're going to clean things up and make it easier for all of you. Frequent collections is the first sort of issue that you're going to run into in your games. This is where you're allocating things willy-nilly, you know, just an int here, vector3 there, game object here, component, maybe you're going to make a whole new byte array, a heap, whatever you need. By doing this all the time, especially in your update loops, which is getting called many, many times a second, or especially your own GUI calls, which are called even more if you're doing any editor code, you're going to collect a lot. What that's going to look like, I've got a profiler image that'll come up in a little bit. You have a little memory location there, you're going to see it grow, drop, grow, drop, and grow, and drop. And you get this sawtooth pattern. Every time it goes up, you're likely to see a big spike in how much time you're taking to render a frame. And that's bad, but if it's happening frequently enough, you can manage it, and you can make it workable, especially if you're still within the amount of time you need to spend within a frame. So if you're hitting 90 frames a second, you've got 10 to 11 milliseconds to work with. If you're only running 5 milliseconds each time, then you've got a little bit to spare. If you can keep your GC spikes underneath a certain amount, you might be fine, but you still can't control when it's going to happen. So some things you can do, you can allocate things less frequently, you can cache them, do it up front. So during your start or your awake methods, go ahead and get anything you need. So instead of calling find object of type every frame during update, just do it once, hold on to it, and just use it every time. You can also do this if you need to reuse a list or a byte array. Rather than newing it up every single update, just hold on to it and clear it at the end of your update or at the beginning of your update, whenever it makes sense. There are certain rare situations that I've run into a couple times, so I wanted to mention it. You might actually want to expand your mono heap. There's some instructions on how to do this on the garbage collection sections of Unity's documentation. Basically, one of the edge cases you could run into is if you're near the maximum heap size, which will grow automatically for you, but you aren't pushing it too hard. Instead of growing, it'll just collect. So you end up bouncing just a little bit near the top of, let's say you're at 128 megabytes there. If you stay within a certain amount, you won't trigger the allocation of the second heap to double the size, and you'll just keep collecting over and over and over again. So you can kind of stretch it ahead of time is what I kind of call it, and I found that works in a couple of very rare situations. Just keep it in mind if you ever need it. The other thing you'll run into is tall spikes. So those are garbage collections that you'll see inside your profiler if you bring that guy up. This is what happens when you have a large number of items on your heap, whether or not you're using them or collecting them. So I said in the last slide that you want to pool things, right? You want to hold on to a bunch of things and just reuse them over and over again. If you've got 10,000 of those, you might start to run into problems where every single time you collect, it's going to take a lot of time. Like I said before, it's mark and sweep, and we stop the world. So during that mark phase, we have to look at every single thing. Whether or not it's available for collection, we don't know yet. So we have to stop everything. We need to look at every single object, 10,000, 20,000, 30,000, 40, 50 of them, and you see a linear scale in terms of the amount of time that it actually takes to look at that, even if you don't collect anything at all. So pooling is a C++ trick that you see all the time. It can be dangerous in Unity if you're not careful. So if you can reduce those, that's a really good idea to do, but only if you're seeing really, really big spikes. And you'll notice right here and right here, this red line is the memory. So correlated with this spike, there's a drop. And we go up again. Correlated with this spike, this is a drop. It's a very severe kind of contrived example that I put together here just to get this graph, but it kind of shows the point. That's the profiler in general. Hopefully you've all used the profiler if you're trying to solve these kind of problems, and there's a couple of different areas in there. I wanted to show, again, an even more severe garbage collection here, where we actually didn't impact the frame time at all, or at least it wasn't tracked inside the profiler. The nice thing is we probably freed up a lot of space here. That's a pretty significant drop on the graph. And we're staying pretty linear as we go along. In this application, we were not allocating very much at all. And during our garbage collections, we managed to keep it usable, which is, this is the ideal graph, basically. The other ideal graph is the same thing, but a horizontal line that never changes, right? And then if you never change, you never collect, then you're fine. So last piece of data before I kind of end things up, because I'm running a little long. This is my this is a presentation that I want to expand out, and so cutting it down is an adventure. So I'm kind of like rushing through a lot right now, and I apologize for that. Some data that I collected in Unity with the Bone Garbage Collector in terms of objects for a big spike. It takes approximately 4 milliseconds every single garbage collect per 25,000 objects that you have inside Mono's heap at any given time. So you can make a new array or new list 25,000 items, right? You're going to start to see large collects. It goes pretty linearly, and it compares to about 3 milliseconds for the same thing in modern.NET. About the same application, just kind of changed from Unity to just a console application, doing the same thing. And the code used for this, don't worry about it too much, but you're looking at roughly 750 bytes per object that I'm putting on the heap there. I make a whole bunch of them, and then I make a whole bunch of them per frame and then throw them away to cause allocations to happen and start to track that over time. The other data, the 3 milliseconds, I got through some of the modern tooling in .NET for collecting some of these events as they occur during garbage collections. So I know that's a huge brain dump. I know that's a lot of information. I know it's not the most exciting topic in the world. I will happily share out this deck at some point, which is why I've got some documentation on there. The first one there is some more information on boxing. We've got Unity documentations on memory management and garbage collection. The last one is one of my favorite tools, which is a Visual Studio plugin for identifying some of those invisible allocations I was talking about, the secret allocations. When you are boxing, just have a tool tell you about it instead of just trying to find it and realizing suddenly that this thing that didn't show up in the profiler. Oh yeah, fun fact, not every allocation is going to show up in the Unity profiler, because the Unity profiler, as far as I understand, only tracks data that is in the C++ side of the engine. So if you make a new thread and you start to do some stuff on that thread, Unity just can't track it right now, which is unfortunate. So you need to be a little careful about trying to identify what's happening, marshal things back onto your Unity thread if you're trying to track down issues, and use whatever tools you can. So yeah, are there any questions? Nothing? Yes.
Have you seen a difference in fragmentation and timing between small applications and large applications?
I've not tracked those explicitly. Large allocations have their own special space in the Bone Collector, and they do a lot of things. I deal with a lot of smaller ones, and then I pool large objects and reuse them typically in my workflow. So I haven't done explicit experiments there, but it's probably worth doing at some point, putting together a benchmark, because I bet it would be very interesting. In modern.NET, in modern collectors, for those who aren't familiar, there's usually an entire special heap just for large objects, right? And only the small ones go through a generational process where, based on how long they've been around, they get collected more or less frequently. And the large object heap is special and magical and does different things. In Bone, in our collector here, there's kind of a little isolated area, but they're still treated very similarly as far as I understand. But there very well may be different patterns. The collector will try to use the same memory space for large objects and reuse it over and over again, rather than just give it back and let it go back to small objects again. Yeah. Lots of stuff. Thank you.
So
Do we know who's next?
I think it's
So
Chad.
Talk to Deb.
Oh, is it me?
Probably garbage
Oh,
collection,
boy.
one that comes up.
Yay,
big or
Chad.
whatever.
Hey, hello.
There's nothing you can do about it.
Yeah.
Garbage collection is
The answer is
fun.
email Lucas.
Yeah.
Do a lot of garbage collection.
Everybody does, right?
Yeah.
Challenge.
This is also
There's too
Sweet.
much to go through that. A short amount of time, it's hard to do.
Actually want to pick your brain later. It's useful.
a useful brain.
A useful brain indeed. All brains are useful. All right. So my name is Chad Jenkins, and I've worked on a number of indie projects using Unity. I've worked on Kerbal Space Program and Universe Sandbox 2. Both of those are huge, sprawling sandbox games that have been in development for a very long time. Today, what I want to talk about is sort of the design ethos that we use at Tetragon Works. And Tetragon Works is my new company that I founded here in Seattle. And we are working on a new game called Phantom Brigade, which is a turn-based tactical RPG. Now, let me see if I can get this to pause. Don't keep going automatically. Thank you. Yes, so we're a small indie development studio located in Seattle, Washington. And we're building this big, ambitious game about giant robots stomping through cities. We have a lot of very specific design requirements. We want to be able to destroy all of the environment. We want to be able to have highly customizable robots, be able to rapidly prototype and iterate as quickly as possible. Now, the nice thing is that in some ways, Unity is uniquely set up to do this. We very much believe that artists should be using the tools that they are most familiar with and they work best in. As a technical artist, which is my background, you have people working in 3ds Max, Maya, Modo, all different softwares. And you can develop Python scripts or specific scripts for those, but they don't work with other 3D applications. Their data can be different, their formats can be different, ends up being very tedious. The nice thing is that in Unity, we can ingest 3D files from pretty much any program out there, and that allows us to have a unified pipeline and workflow inside of Unity. So we want to have a lot of value in this game. We have a lot of environment assets, varied characters, lots of levels, many scenarios and items. I mean, this is a full-fledged RPG, so there's a lot of stuff. So we have focused on automation to help us out and really allow us to produce a huge amount of content. Our goal here is that anytime a content designer is making content, an artist is making art, they're making artistic decisions during that entire time. We don't want them to have to set up materials in Unity. We don't want them to have to set up settings, colliders, name them, put them in folders, any of that. And with the asset processing tools that Unity gives, we can actually do that all automatically and ensure that the standards are always met. We automatically parse all the assets when they come in. So literally, they can produce something drop it in Unity, and have a game-ready asset in minutes or seconds, depending on the complexity of the object. So we just want to eliminate all of the boring stuff in development. And the first thing that we applied this on was the level system, which you see here. So we're using kind of this industry standard approach of doing modular geometry. We have an average grid size between 40 and there's 100 by 100 cells. So you have literally thousands of modular objects in the scene. And we want to be able to make these as quickly as possible and prototype them as quickly as possible. If you were doing this in a 3D software or statically creating it, would have taken a very long time to make a scene like this. So what can we automate? And we're going to make them automate everything that we don't want to do as an artist. We try to eliminate any busy work at all. So all the shapes that we have authored, they have to be a complete watertight tile set. We don't want any holes. We don't want anywhere you can see through the meshes. We would have to export hundreds of models, manage shaders, materials, vertex data, the things we use to color the vertex so we can have all these different material properties on one object. And we need to place thousands of objects manually. As you can imagine, if you have a small studio, this becomes increasingly difficult to do. The majority of this game has been built with 2 people. That's me as a programmer and 1 content artist. So we have done a massive amount of work in a small time. So one of the first things we did is we got rid of the boring part of tile set and modeling. What we actually do is we cut the tile sets along these geometric planes. We bring that into Unity and use C# to automatically swizzle them into every permutation of the tiles possible. So a full watertight tile set can have 256 different permutations that would take forever to model. So all we do is we author a few pieces of key art, and then it generates every variant of it by automatically moving them around. So this allows us to test a new tile set in the game and have it fully playable in 1 day, as opposed to months or weeks, which it might take with a traditional tile set. So, nice thing, C#, the Unity API is blazing fast for iteration. You know, it's a lot better than traditional tech art environments like the 3D scripting softwares that you use. And we generate all the shapes in Unity and easily export them to OBJ. So we actually put them in Unity and bring them back out as OBJ as a foundation for artists to work on. And then OBJ is, of course, sort of like, I guess you could say, Latin for 3D models. It can be sent anywhere. So this is the final art that was generated and processed by our custom import scripts. When we assign bitmask IDs to all of this, you can see all the permutations of a tile. This would have taken forever to do, would have taken forever to manage. It's hundreds of files. If you can imagine trying to set the materials on this, you'd be pulling your hair out in no time. Even the most dedicated artist does not want to be doing this. So now we can just drop a single file. One of my artists uses SketchUp. Another one uses Modo. We have ones that use MyLT. FBX, doesn't matter. Throw it in there. It'll go ahead and chew it up and output everything we need automatically. And assign batched, baked, and atlased textures for us to reduce the draw call count. So how do we use this in practice? So we don't place anything manually. We just fly around the scene and we click on these lovely, nice colored cubes. So this is what it looks like after Unity does its magic. We go through and we have a simple system that processes all of these little points, essentially as voxel data. We consider that to be a spot. And what it does is it generates this completely contiguous mesh. And it's an abstraction of what level designers do when they manually place the modular blocks. If you want a building here, which 10 objects do I have to place next and where? We don't have to worry about that because that's not really an artistic decision. We let the code do that for us. And this scales up. So now we can wrangle 100,000 point grids easily, and you can just paint. So our first pass at getting a gameplay level is to literally just paint it. And this is extremely fast. We have been able to author an entire new level in hours, if that. All assets, all the qualities there, and you can just see how easy this is. This is actually in the Unity editor. And the fact that Unity's editor is so extensible allows us to do this. We can just raycast against physics objects, we can create all the data, we can instance it, and then we save all this out to a very small binary data file that we load at runtime. We literally build the scenes on the fly. And the great thing is that Unity 5.4 actually introduced GPU instancing. Thank you very much. I'm beyond thrilled with this, and we can actually use instancing in these tile sets. So now we're able to take what would have been potentially 20,000 draw calls and turn it into 1.5K. And this can even run reasonable frame rate on an Intel GPU, the Iris and integrated cards, which is nice. And we hope to get the performance even better. So now that we have all this wonderful data, we have information about how the objects are shaped, that allows us to do a lot of really cool stuff. Our authoring tools are actually context aware. So you can see, when you paint down gantries and stuff, we're only going to put the permutations that are viable for that surface. So this allows artists to really quickly paint girders, walkways, gantries. We want a very naturalistic feel to making a level. Okay. And the great thing is now that we have this data also stored about the volume with these 8 corner points that we have in the grid-aligned nature, we're also able to do real-time destruction and damage, and this actually is fully physically simulated as well, so it will stop objects. We can use the physics engine, have debris, pieces of your mech can fall through a building and destroy it. All this kind of stuff would have been incredibly tedious if we had to author bespoke art for every single one of these things. It would have just been completely untenable. And we're also doing shader damage, which is supplemented with the edges and interiors. The entire system was designed to be as open as possible and leverage Unity surface shaders. It's convenient and fun to debug and polish something, and you can look at your half-ready code, get it into scene view, and then test crushing walls and stuff immediately. So you can see the explosion here. All the pieces have actually penetrated the building, blow it out. We automatically swap in contextual interior meshes based on the tile set that we've set, so we know to put rebar and stuff inside a building. And that means that we only really need to author these damage skirts for one tile set. It means it takes a very short amount of time, which is nice as far as we're concerned. And the great thing is that we have all this data, we also get pathfinding for free as well. So we actually generate the entire navigation nodes automatically by just doing pattern matching. We know where the edges are, we know where the traversability is, we know leaps and bounds. That notifies our animator. We want it hurtling over something. This is things you would normally have to do manually, and we don't have to do any of that. You can literally paint a level, press play in the Unity editor, and instantly be prototyping, testing it. So that allows us to be extremely rapid in our development cycle. And this really wouldn't be possible with other editors. And we also use material property blocks. That's how we get these colors. We're able to save draw calls. We don't actually duplicate the materials at all. And we can actually insert these bigger custom designs, and our system will slice them up. So anytime our artist wants to make really cool hero art, as you would call it in a tile set like this, it actually gets sliced up so it natively works with the damage as well, and we don't have to spend a lot of time. We can actually save these things as brushes and just stamp them down anywhere in the level, and the buildings will automatically cohesively heal themselves, become a playable, interactable game object, which makes procedural generation of the levels also a lot easier to do. Now, we didn't just do that for the levels, we also did that for the mechs, and they benefited from automatic placement and processing. Our entire mechs are built up of a bunch of little armor pieces and things that are manually created. It would be a real pain to try to deal with trying to export all the pieces for these mechs. They have interior armor, external armor. It's a whole mess of things that we would need to do. And we don't want to have to export them individual files. We don't want to individually bake them. It would take forever if we had to load up external software to bake every single one of these meshes, name them, go through the entire pipeline process. Great thing is we can just bulk import this data into Unity and let it do all of our baking. We have AO baking inside Unity that we use to generate the curvature maps, the AO. The materials are baked into the vertex color. So we basically just read the material IDs here, and we bake that into the RGB value of the vertex color, which allows us to render this entire mech in a single pass, one draw call, because all the metallicity and PBR values are actually stored in an array on the shader. So very fast to iterate. You can go ahead and put together an entire new mech in a day. And we also use this for procedural animation. This allows us to do real-time dynamic joints. This means that we can animate them with ragdolls, we can move them freely, And then our animator doesn't have to even worry about this. It doesn't matter about their IK setups in another program. We do this all at runtime, so it's 100% consistent. And our animation data is actually very simple. All they have to do is generate keyframe data, and then we generate those. And this is our shortcuts for texturing, like I was saying. Since we want to be able to customize all of this, we actually generate these curvature maps by running a small cellular automata in Unity, which generates them all automatically. It makes it look like these are beautiful hand-painted textures. That's actually not what they are. They're just materials on different RGB values for each of these, and then we have a separate PBR property value for each one of those materials. And it's also very efficient because it's just one draw call. And we also use data-driven design. We offload as much as possible into external files, all of our items, localization, scenarios, levels, constants. Even how we control the units is extracted into YAML data. And we can quickly iterate, we can actually load this up while the game is running and change how weapons work, how pretty much anything in the game works instantly without even having to rebuild. So it allows us really quick design. So to kind of summarize, what Unity helps us to do is we take the most time-consuming production art responsibilities away from the artist, we automate all of it, and we allow the artist to work with concerns closer to concept art and making creative decisions, because that's really what we want our artists to be doing. We want to think about objects and not mechanical decisions about file names, baking, trying to assign materials, and all that jazz. Like, it's not anything we want them to worry about. It allows us to prototype new systems, iterate on them faster than usual with a data-driven approach and easy debugging and visualizing. Open design, powerful APIs are lifesavers, and that's why we like using Unity. Anybody have any questions? Okay, so, all right, pick one.
Start with our hosts.
Yeah, what's up?
I'm assuming you're using multi-cubes because the 256. I'm assuming you're using a variant of multi-cubes.
Yes.
For your, so when you have to get different tile sets.
Mm-hmm.
To get different tile sets within the voxel data, do you tag certain voxels with the tiles that they should be using, or do you just kind of?
So we have everything is stored as a bit mask. So it's 8 bits of data which control the different points. There's 8. There's 4 on top, 4 on bottom. That's enough for the volume. We have an additional descriptor, which is a bit mask that contains data about rotation, tile ID, which is these variants you see, like the pipes and things like that. And the great thing is that we can also read this data natively in the editor. And we know, oh, pipe, put the center pipe model, because we can do parameter matching. We can basically really quickly, just with bitmask tests, find any sort of permutation extremely quickly and match them and load the tiles up. So you can do this in real time in the editor, and it's actually very fast. Does that answer your question?
Yeah.
I actually have a whole talk I did at GDC to some developers who are interested. I can show you that. It actually shows how we go through the process of slicing the voxels, how it works. The great thing is, like, literally, we just added woods, like a whole outdoor scene, and we got that working in under a day. So this is a really nice workflow.
We have time for one more question.
Sure. What do you got for me, buddy?
So, with a system like this, are you guys planning on using it for modability? And is that something that it would be very useful for?
So the great thing, do you have more to say? Sorry.
Yeah, and the last part of the question. I think you threw me off. Just let's go with the
Oh, sorry.
modability.
So we actually have considered modding from the ground up. It's part of the reason why we're using YAML. You can just edit it by hand and completely modify the entire game. We export from our tool set a binary file, which is actually very small, which contains this entire data. So what we can do is we can basically release an asset package that people will be able to load into the free version of Unity. They'll be able to use our tools to make any kind of level they want and export and read the data in with no problem.
Yeah, that was actually the second part of my question. So will any of this be available as an easy asset for people to use in other projects, or will it just be for Phantom?
Well, we've developed it internally for our studio, so it's pretty much designed for our needs. We just, we only have like 2 or 3 people, so as much as I think this would be really useful technology for other people, we just don't have the time to make it a asset that I would put in the asset store, per se. The amount of engineering required to make like a completely abstract system that people can, in the documentation, it would be great, but we'd probably do that after Phantom Brigade shipped, if at all. Because right now we just gotta we gotta make this game. Yeah. Does that answer everybody's question?
Probably not.
All that Sean's gonna allow us.
Yeah, I will be here. Feel free to pick my brain later. I can actually show you how this works in game. If you have any questions, yeah, I would be happy to talk with you.
Cool.
All right. So hi everyone, my name is Rohit. I work on Collaborate with Unity Services.
Hi,
Hi. I know Stella already asked you this, but how many of you are programmers? And how many of you use Unity scripts? Nice. It's more than I was expecting. So this talk is mostly going to be conceptual in nature. On the surface level, it's going to be about writing more flexible codes for faster iteration. But what I'm hoping is that even the people who are not programmers in this room will be able to take these concepts and apply them to their game development. And I want to talk about making things better for making things better. And what I mean by that is a lot of the time, innovation in game design comes from making a prototype and then playing it, or having other people play it, and then iterating it, and then iterating it, and then iterating it, until everyone likes it but you, and then you polish it, and then you release it. So I want to make that process easier for everyone involved, especially the programmers for this talk, but hopefully other people will get something out of it too. And first thing I'm going to talk about is composition over inheritance. And this is something that's on the internet. You can find it on Wikipedia if you like. So if you want to look up what I'm talking about later, you just look for composition over inheritance. And I want to talk a little bit about inheritance first. So all of us have some kind of experience with the word inheritance. We know something about it. And basically it just means taking over ownership of something from someone else. When we talk about it in computer science terms, it's more like a trait. So just because you inherited something from your parent doesn't mean they lost it. So that's the inheritance we're talking about. And when I say composition over inheritance, it kind of sounds like I'm saying inheritance is a bad thing and you shouldn't use it. But that's not really what I'm trying to say. So let's try to talk about some of the good points of inheritance. So we just brought up the concept of ownership. So I'd like to talk about why even have more than one owner in the first place. Because in programming, it's totally valid to take out all the logic and just put it all in one file and it'll work. But this is rarely, if ever, encouraged in practice. And the reason for that is because, believe it or not, software engineering is one of the hardest things we do as human beings. And to be able to keep all of that logic in your head at one time is nigh impossible. And if you put it all in one place, it will get entangled inevitably. People will start referencing things they shouldn't. It'll all become spaghetti. And so there's this principle called DRY, which is do not repeat yourself. I don't know why it's not called generate or do not repeat yourself, but I don't make the rules. And according to this concept, you should basically repeat yourself as little as possible. So basically this means that if you're writing some code that's going to be used in more than one place, you want to put it in one place and tell everyone to just go there and run that code from that place. And the way we do this is by separating concerns. We just put things in different classes. We decide who owns what piece of the logic, and we give that piece to someone. And the way we decide who owns what piece of the logic is by deciding what an actor is and what they want to do. For example, if I say, here's a teacher, and the teacher should do these things. Here's a student, the student should do these things. If I'm a teacher, it's not my job to do the student's homework. So that's something the student owns. And this way we can separate the concerns. So then why do we need inheritance? Inheritance is, there's going to be traits that the teachers and the students both share because they're both human, for example. And these traits can be put inside a human class, and then the teacher and the student can just inherit from that. And that's where inheritance comes in handy, because now you're not repeating yourself as much as you would if you were trying to put all of that code in both the teacher and the student. So this brings us to composition. And composition is kind of the same thing, except this time, instead of deciding what someone is, like saying I am a teacher or I am a student, you try to think about what someone does. So you just basically say, for example, I would say I am Rohit and I do all of these things. From the fact that I am Rohit, you can't really tell anything. But based on the list of things that I do, you know what I am. And this is basically composition, and each of the things that I do will be encapsulated and be able to be replaced by something else. And this is very good for fast iteration in game development, because if I'm trying to make a game, let's say a shooter, I can easily turn it into a brawler, because all I have to do is replace that one behavior with something else. It's kind of like a Pokemon learning a new move, right? You say, Rohit wants to learn a new move, but he only knows 4 moves. He already knows 4 moves, and you just like swap it out, keep it done. And this just kind of leads a little bit to more verbosity in the inspector for Unity, because what I'm really talking about is the component system. So if you think about it, when you load up Unity and you look in the inspector for a game object, you will see a whole bunch of things. And sometimes you will see sprite renders, colliders, some scripts you've added. And all of those things are components. Sometimes we do things like create a player controller and put most of the logic in there, and then that's the one script component on that player object. And what I would encourage you to do is to try to split that up and see how you could break it apart into different things. And I have an example here of that. I don't know if you can see it.
Nope.
Let me just...
Yeah, we all know what it is.
It is an inspector.
I can't zoom in right now.
Oh,
Oh, there we go.
There we go.
So kind of like this. This is not a perfect example, but it's a step in that direction. So there is a player controller still, but there's a lot of things that have been split out from that. And each of these things are, each of these things rely on the player script, but they're all replaceable, and you can turn any of them off without losing anything, and you can add more without breaking anything. And what makes it really tick is the state machine, which is another really important tool if you're trying to create games and iterate fast, because knowing the state of your game really helps with not creating any more bugs. And if you have state machine, then you can create a script whose job is basically to say, oh, I'm in this state, I should do these things. And you can use interfaces to abstract that out so that when you're doing this, it doesn't care what kinds of behaviors it has attached to it. And that's basically most of what I was going to talk about today. I was also going to talk a little bit about collab, but I think Marissa will tell you that.
Yeah.
And I think I'm open for questions.
So one thing I've always wondered about with Unity is the get component call, so continuous functioning. Is that so optimized that it's pretty much safe to call within a game, or do you recommend that at the very start of the game, all the components wake up and say, okay, who's one of my neighbors? Give me references to each other. I'll store those in local variables and never call get component again.
So I would advise to call get component at the start and save the reference if possible. But if not, calling get component on components of the same object is much faster than calling it for something somewhere else.
You know, select the multiple components of the same type on a object so that the component will have this, there's no concrete definition of which one gets returned, so that's another thing on it.
You can't limit that.
You can limit that, but by default, it's not.
Any other questions for Rohit? Because we are ahead of schedule, so if you wanted to ask Rohit another
are there any decent ways to sort of mitigate inspector clutter using this approach?
So this,
Besides making a custom inspector, which is the biggest pain in the ass in the world.
so that's a good question, and the reason that I emphasize that this is for iterating fast is because that's the result of this approach. You end up with a lot of inspector clutter, which is not necessarily a bad thing if you're prototyping, because you don't really care about that.
Sure.
But yes, if you already know what you're going to make, and you know the hierarchy, you don't need to figure anything out. With a component model, you don't really need to know anything when you start, because you don't care what's inheriting from what. Right? You just care about the behaviors, and you don't need to figure out what's common and what's not common ahead of time. And that's the major advantage of the component system. But if you know something that helps you use the inheritance system instead, then that will definitely help you just cut all that clutter out. Just go for what you want.
So those are all mono behaviors?
Yes, all of these are mono behaviors.
Isn't there like a cost associated with having mono behaviors?
Yes, there is.
So why do it this way instead of just doing it as a data component list?
So doing it as a component list will slightly limit your options. This way, so a lot of the advantage of this is being able to change the public variables, right?
Yeah.
That helps you reuse them with the different game objects as well. And so just having them in the inspector is very useful.
Yeah.
And the cost is not really that bad because we're trying to focus on just getting to the point where you know what's fun and what's not. And we're not trying to care so much about optimization right now. And this kind of thing is much more useful in that regard than trying to save time.
I was hoping we'd have religious questions. I don't know if we have enough time for religious discussions. So these are all good questions. So does anybody else have anything extra hard for Rohit? He's doing really well.
I have a question for you actually. It's very pure, right, to have that broken down into so many small components. But I kind of live in a world where I've got I've got a few larger things that do a lot of work. Do you have any suggestions for purifying it slightly, for going from the reality of code that other people have written that has evolved over time organically to something that's a little more inspectory? Or is that just refactor?
So I have two
right?
answers.
Okay.
So the first part is everyone's needs are different, right? So whatever you're doing, use your best judgment, right? And the second answer is you can't change the fundamental architecture or something. Right? Like refactoring will not make you happy.
You always think will make you happy.
You're
Wait, just get different
saying
problems.
this with a religious answer.
Might make you happier.
It makes me happy. I have garbage.
So in this example, what are you using for the communication model between the components? Like say the hit point renderer wants to know the hit points change.
Right. So there's different things you can do. One thing you can do is to go pure component method, right? Which is where the base class you're using, like player, has all these methods inside it, and it decides who to call and what happens. So basically, the state machine deals with everything. So the state machine will basically be an interface. Everyone's calling that interface saying change the state to something else, and then the player class, which contains the state machine, decides what to do with that state change. The other method is to use the pub sub model. Right? So you have events and delegates, and then every one of these fetches the base class that it's relying on, and then decides to subscribe to some event, probably state change, and then decide what it needs to do with that.
In a more specific, would you suggest relying on Unity's event implementation or .NET's event implementation?
I want to say neither, because the moment you go with that approach, you end up introducing some kind of asynchronous events in there, and that will usually bite you if you use this method. And you will have to pay very careful attention to how the scripts get executed. So if you use Unity's event delegates, I know that you can easily change what's happening based on the script execution order. I'm not sure if that applies to .NET. I think it does. But either way, you have to mess with that. So to avoid it completely would be much better in my opinion. Alright.
Yeah, it does, yeah. It's great.
If you reset it,
I'm gonna ask you to help me demo in a few. So that one. Collaboration, which requires a second person. Hey, I'm sleepy because I got up early, so I have to pretend to have energy. I'm here to talk about. Hi, Matt. How are you?
I'm good, how are you?
I'm sleepy, but we covered that already. I'm here to talk about developer services. So a lot of Unity's developer services are aimed on things that are outside of making your game, but make your life easier. It's like one example of that is like Cloud Build. I work with Richard, who's a marketing guy, who went out to find a team to make multiplayer demo. And he wanted to see continual builds of that. And so we ended up having them turn on Cloud Build so that he, marketing dude, would not have to like download a version of Unity, figure out their source control, or have them like continually throwing builds his way. So it's like things you wouldn't necessarily want to spend your time dealing with. There's a lot of developer services. And I'm Marissa. I'm a product manager. I work on Collaborate, Cloud Build, the launcher, and the developer dashboard, and a lot of different things. As a product manager, I mostly talk to people that use Unity, ask them about their problems, and figure out how to solve them. So for this, I'm just going to do a demo of Collaborate, Cloud Build, and then a bit of performance reporting. So as of today at Unite Europe, we announced our pricing for Unity teams, and that's on our blog post, and I think that changed up until the last minute, so I don't have those numbers off the top of my head. But we're actually completely free from now until October, so you can check out Collaborate and Cloud Build and see all the features without having to pay us any money. So please do that. And so I'm just going to hop into demo, because I would much rather show you things while I'm talking. So I'm on 2017.1 F1. This is the latest build you can get on our beta site. So 2017.1 will be coming out in July. And this is our tanks demo, which is our multiplayer demo. And right now I do not have Collaborate set up. So the reason why we built Collaborate was because a couple years ago we went and talked to a lot of different teams and a lot of different Unity users. And we found that about 80% of people, and we also did a lot of surveying, didn't use any kind of source control. They used USB sticks, they used Google Drive, they used Dropbox. And a lot of those smaller teams were more about like, I want to work with another person, I don't want to manage anything. So for Collaborate, we started out with how do we offer really simple project sharing, just integrate it directly in the editor and make it as easy as possible. And so for that, I'm going to click Start Now. And I've got a bit of a project, so that turns on. I'm also going to click this tab, which I could have gotten to from the little people icon down here. And I'm going to make publishing my project. Publish now. And that'll go, and while it's going, I'm going to invite Rohit to my project. Are you Rohit at unity3.com?
Yeah, but I'm trying to reset my password for that.
Okay, excellent.
We'll see if I get it.
Oh, well, hopefully we can show you the collaboration aspect of Collaborate. That'd be good. So here we have things like a simple history, and I can make kind of fast and easy changes. And so Cloud Build, which I mentioned, is a fast and easy way of having continuous integration and having builds set up that are just automatically running on Unity's cloud without you having to deal much with it. It's a couple clicks if you're not using Collaborate, like it works with any source control. But with Collaborate, we just click build now, We're gonna flip this guy on, and then sure we'll build for Mac. And you can set up a bunch of different build targets. You can even get really specific about, like, I want this scene. So if you're like making a mobile game and you have just a test scene that is for your artist for all of the art that they want to be able to view, you can have that continually running so they can swap in and out art so they can just see it on the device, which I think makes a huge difference. And then we've got auto build turned on. With Collaborate, that means that every time I'm doing a publish, I'm getting builds that get keyed up. Boop, next build, starting builds, and this will be a build history. Are you waiting on your password still? Huh? Oh. We're going to invite a different version of Rohit. Hey. Let me, is this right? Gmail.com. Yeah. My project settings update was just because I turned on Cloud Build, so we're backing up everything that's in your assets folder and also your project settings. So next time, like, as Rohit is opening up his version of Unity, what he'll find is in the cloud, he'll have this tanks, and this is everything I have been added to, which is an awful lot of test projects right now. That he can download from the cloud directly onto his machine. We'll be able to start working it right away. Getting it?
Yep.
So like a big thing for us has been a lot of like how do we get better integrated? And to that end we have just a lot of small things like see all those changes in your project browser. And then things like being able to publish, being able to revert, see differences from right click menu. And the one I wanted to show off is scene merging. So under the covers we're using YAML merge, smart merge, which I will demo in a second. Smart merge. This guy, which I want to mention because, like, regardless of whether or not Collaborate specifically is a good fit for you, this tool is one that's worth checking out. And my team also bug fixes for it, and we would like it to always be working better. Because as long as you're making you're changing different parts of the scene in Unity, it will merge. The only time we're getting comments when you're like changing the specific component in different ways. But we would like to solve the problem of how to remove that pain rather than just give people more workarounds. Yeah, move something for me. And like mess around with the scene a little bit if you would. Because I just want to show off the quick the soft lock feature. So we added this in progress icon, which tells me that Rohit currently has unpublished changes, so that if I am in a scene where I want to be like more cautious about who's working in the scene, I can be like, hey Rohit, what are you doing? Publish your changes. I've got a bunch of changes I want to make, just so that there's greater awareness of who's working on what. Right now we have this set just for scenes and prefabs, and we've talked about expanding it to a lot more things, and that'll kind of depend a lot on the feedback we get of whether or not that's the next problem for us to be solving. And I'll move hopefully something different. Did you change something dramatic enough? Yeah. Make a move or something. I mean, you might get. We'll see. Oh, change the exact same object. So in this case, we can see the differences. This will just pull up the YAML files, which will tell me like he changed the X, I changed the Y. And I could do a launch an external script tool to do a merge, or I could choose mine, or I could choose his. So I'm just gonna choose his. Oop. And just throw away my quick little move. You wanna move that object again, and I'll choose something else. Oh, you moved something else? Oh no! This is why communication is really important.
Just use something that's not run.
Alright, an update. Where'd you go? Did you move that around? Yeah. So that's a good way of being able to work around each other a little bit. And one of the features we're planning on working is actually in scene commenting that we have a prototype for. So that you can say, like, change this to this object, so you can either choose to work around each other or use that for giving very specific feedback. So that's where Collaborate is. We're out of beta of 2017.1, planning on adding a lot more features. Kind of further down the pipe, we'll be looking at things like third-party source control support, so that you can use whatever with us. But right now we're committed to kind of having like very simple project sharing, aimed at just the happiest, safest path for our users. Oh yeah, so with Cloud Build, we have, this is the developer dashboard, developer.cloud.unity3d, just a bit of a mouthful, and a bunch of these features are moving more to the editor, but right now you can mostly find them all down here. So this is like a demo prototype from a while ago, and I can have like, here a bunch of different builds, you know, I can play my WebGL build, I can download different files. One thing I can also do is I can create a share link. So if I just click share, gives me your URL. So if I have like an Android build, I can just send someone the APK by like, go download it by hitting this link. I can also revoke this link, which I was trying to do whenever I'm doing demos, because that's has been a problem when showing off other people's games before. I believe that. I didn't do that one. Someone else did though. These are important things. One of the other features I wanted to mention was performance reporting, which is not on this project. Let me go find. So Unity's performance reporting product right now, it's part of Plus and Pro, and you get it as part, like for free as part of those offerings. It's exception reporting for all platforms. We're doing crash reporting for iOS, which is for the full stack trace. That's in 5.6. Android will be in not this version, but the one after that, 2017.2, and then also Windows and OS X are coming out soon. And like for this one, like it's pretty straightforward thing. Like here's my stack trace. I can see how often things are happening. I can see what versions of my game was affected by, and also what OSs were affected by it. We're going to be redesigning this website to make things a lot nicer in the near future, and also doing things like making it so people can mark a crash as a result for a specific version of the game. So they feel like, don't tell me any more about this crash, but in the future, if it comes back, let me know about it. So yeah. Oh yeah, other things. So with Unity Cloud Build, another feature that we're adding this year is push to store. We want to give people the ability to push directly to different stores. And I think, and Xiaomi is actually our first one. And so on the Unity Cloud Build, you'll be able to upload a build, choose your platform, enter your label, and submit it to the store. And like longer tail, we want to do that with a lot more platforms to make it even easier for people to like submit things to the Unity Asset Store to track which build you're sending where, and to make it easier for you to get on more platforms that you wouldn't necessarily like go out of your way to be like, how do I integrate with Xiaomi? Versus being able to like, let me just walk through this path. So yeah, more information on like collaborating cloud builds on unity3.com/teams, and that is my spiel. So questions I can answer.
So the ultimate question, does this mean that I can build on Windows and push straight to, build an iOS build in the cloud, push straight to the iOS store, and then get it on my phone? Because that's the dream.
That is the dream.
We share these dreams.
Yes, we share these dreams. I
I'm a Mac
dream
for a
that same
reason.
dream. I dream of an Apple that is easier to work with. Okay, yeah. So pushing directly to like iOS, not so much, but you can push like you can set up iOS test builds on Cloud Build, so you can push those directly to your phone. So that is there, but as I recall, it's like a couple extra hoops, whereas like Android is stupid easy.
So if I've got a bunch of cloud builds configured, can I wire it all to one big execute button, or is it scriptable?
Yes, it is. You can wire it up to one big, yes. And you can do like clean build all, whatever, and you can have an auto build. And there are also a bunch of like pre-build hooks that you can set up or post-build hooks, and there's a lot of durability in that system.
So it's nice to see the prefab merging thing because I live in fear of that because I thought prefabs were completely unmergeable. Is that Unity YAML tool? Will that work for existing Unity Pro customers, or is that only 2017?
That works right now. You can download it from the website. It should work on pretty much any version of Unity. Although if you get newer versions of the tool, you're getting more bug fixes from the Collaborate team.
And is that something that you can integrate? I use Git.
Yep.
So it integrates into that as well.
It integrates directly into that.
And then do you have any like advice in terms of like best practices for good merges, like don't move components around?
I'd say like moving components around can be a bit risky. One of the other things is adding new components is, so when you create most of Unity uses kind of like a GUID and kind of like random IDs, but the component list is not random, and so if you add a new component and someone else adds a new component, these share the same ID, and this will be a conflict. So there's some cases like that. We're actually working on a better merge tool, which will be a bit more visual. That's probably further down for us.
When using the C collaboration tool, is the only indicator that somebody else is farting around with the C is that just that red work in progress icon, or is there like a tag on the object or objects?
So right now it's at the scene level. We do want to make it more specific to be like this thing. Right now we don't have the concept of an object ID in terms of the Unity scene level. So it's both on the like the scene and scene view, and then on the in your project browser you'll see the person's name as well. Other questions? Cool. Thank you guys.
Thank you everybody for showing up. We want to, first of all, I want to thank all the board members who are here. I didn't usually try to acknowledge everybody. Renee, who just left, is on our local board, but also Constance and Sella are on our board. None of this would happen I just get up here and smile and wave. None of this would happen without our actual board members. And then, of course, another big round of applause for Unity for hosting us tonight. Let us just hang out in their cool break room and drink their sodas. Thank you very much. Cool. We probably have a few minutes to network while cleaning up.
And there's a lot of pizza left, so please take some.